Today on Engineering Newswire, we're launching drones from tiny boats, recycling shower water, using sensors to prevent serious brain injuries, and making batteries more efficient by going viral.
So what's the biggest issue drivers have with all electric vehicles?
Wow, I can feel the heat in here.
Come on, that one doesn't count. Typically, distance per charge is the biggest complaint and fear of those driving electric vehicles. Now, MIT researchers have started adding genetically modified viruses to help the situation. By adding what is known as the M13 virus to the production of a nanowire array, the viral wire mix is used as one of the battery's electrodes. In this case, wires of manganese oxide, which is a common material for lithium-air batteries, were made by the viruses. Typically, nanowires are grown through a chemical process, but these viruses build their own. The viral nanowires have a rough, spiky surface, which increases the surface area and makes the conduction process more efficient. Not only that, the viral wires also produce a three-dimensional structure of cross-linked wires, creating better electrode stability. This process has the potential to drastically increase power per battery weight, making less charge time go further.
Engineers and cardiology experts at Johns Hopkins University have teamed up to develop a fingernail-sized biosensor that can alert doctors when serious brain injury occurs during heart surgery. In recent lab tests, the prototype sensor successfully detected GFAP, a biomarker linked to brain injuries. According to the study's senior author, Howard E. Katz, real-time testing could occur during surgery by placing a drop of the patient's blood on the sensor. If it detects the protein, it would activate an alarm. The project started 2 years ago when Katz was contacted by Alan D. Everett, a pediatric cardiologist who studies biomarkers linked to pulmonary hypertension and brain injury. To create this sensor, Katz turned to an organic thin film transistor design. In recent years, similar sensors have been able to detect gases and chemicals associated with explosives. The transistors were a good fit because of their low cost, low power consumption, biocompatibility, and ability to detect a variety of biomolecules in real time. The sensing area is a small square, 3/8 of an inch on each side. On the surface is a layer of antibodies that attract GFAP. When this occurs, it changes the physics of other material layers within the sensor, altering the amount of electrical current that is passing through the device. These electrical changes can be monitored and alert when a danger is present.
Aerovel has developed a miniature robotic aircraft for applications in weather monitoring, geological survey, and imaging reconnaissance. Great, another toy company making drones. Except the Flex Rotor utilizes a 4-meter skiff for launch, retrieval, and servicing. This is an unmanned aerial vehicle that can take off and land on an unmanned water vessel. Now that's some algorithmic talent. In its initial flight, Flex Rotor launched from the remotely controlled skiff while underway, climbed out as a helicopter, transitioned to wing-borne flight, imaged the skiff while flying at low and high speeds, transitioned back to a thrust-borne flight, and retrieved autonomously on board the skiff. Easy peasy. When on board the skiff, the Flex Rotor automatically refuels and is prepared for future flight. This provides incredible flexibility for drone coordination, and that's not to mention that this thing currently has a Hawaii to West Coast range. Tiny footprint, big range. It defines efficiency.
Sweden-based Orbital Systems has developed a high-tech purification system that recycles water while users take showers. The OrbSys shower works on a closed-loop system that saves more than 90% in water usage, approximately $1,351, and 80% in energy. According to industrial designer Merda Majupi, only 5 liters of water is used for a 10-minute shower. In a regular shower, an average of 150 liters is normally used. That's 30 times as much. Unlike other water-saving shower concepts, the OrbSys design doesn't compromise comfort, featuring a higher than average water pressure and a stable flow. These features are made possible because the OrbSys works independently from other appliances. As the water falls back to the ground and into the drain, the wastewater gets purified to a drinking quality level. It then gets pumped back through the recycling loop. The water is discarded of once the shower is done. The showers have already been installed at a coastal bathing house in Sweden, and if deployed on a bigger scale, the purification technology developed for OrbSys could be used in taps and drinking fountains in the world's developing countries where water-related illness is rife. Do you have story ideas? Comment below and we'll cover them in the next episode. For the PD&D channel, I'm Megan Zimba, and this has been your Engineering Newswire.